Right, hello. Kind of excited to show you the progress on the GraphQL client for Cerebral. Now, I know a lot of people have been playing around with GraphQL and Cerebral, but I haven't. And I need to understand it. And a good way to understand GraphQL is to try to implement a client for it. But I also had some ideas how this might fit very well with Cerebral. So I also wanted to explore those ideas. So what I'm going to do now is I'm going to show you a tiny demo, and then I'm going to show you some of the code, and talk about the state of the project and what needs to be done to get it to a state where you can actually use it. So I'm just using the to-do MVC here. I'm just writing out my name here. And what I've done is that I've created a couple of, and this is, first of all, this is like creating, like there are two ways to use GraphQL. You can have a GraphQL server, so you only like point to the single entry point, you give it queries and you get the data back. But you can also use GraphQL directly in the client. So if you already have like a RESTful API, or you can even use Firebase, you can actually define the schema of GraphQL and how it is resolved directly in the client. And I think this is the first move we should do, is make this possible, because it's so much easier to take advantage of GraphQL in that way. It's a lot more difficult to change your backend. So this is how it works now. So I have my little database here with one author and a post. The way this works now, we have a Cerebral module GraphQL. It needs to be a module because it fires off signals and it stores some state. And it also has a provider. So what I do is that currently it needs to be named GraphQL. I'm not quite sure how to handle that because there's a computed. And the computed is like separate from the module, so it doesn't know the name of the module. So it might need to be named GraphQL. It doesn't matter. And when you define your module, you have to give it a schema. So here we have an author with a first name, last name. The author can have some posts, and then we have a single post that has an author, and we can ask for a specific author, and we can ask for posts. Cool. And then we have the resolvers. So based on this schema, we define a query, which we see here, like how do we grab an author with an ID, and how do we grab posts. So post is just returning the post, and author, I'm just returning the first one. So here I would typically get the ID, or I guess it's like this, ID, to resolve that, a single author. And then we have defined some fields on author and post that points to another type. So on the author, we can resolve posts. And this is the resolver that resolves posts related to a specific author. And the same for post, we want to resolve the author, so here's the code for that. Okay, so this is how you define GraphQL. And then so that's the module. And then we can go to a component. And what we do here is when we want to use GraphQL with, or a GraphQL query with a component, we import the module's own connect. So you have like Cerebral Connect, and then you have a Connect version for GraphQL. And the reason is that it needs to handle a new type of tag, which is called query. So I'll just show this first, and then I will tell you how it works. So here we can just add normal state dependencies, but we can also add like the query. So here I am querying, I can remove this, that was something I was supposed to show you later. I can create a query, and I query the author with an ID of 1, and I want to show the ID and first name. And I will get the query here, and when it's resolving, it will set the query to like a loading state. So the query object has an isLoading property, which is true when it's resolving the data. But when it's done, it will attach author to this query, and you have the fields. So as you can see here, I get my name, and if I open the debugger, we can see what actually happens here. So what happened when this component mounted was that it triggered a query in one direction. So it triggers a query towards Cerebral, and we can see the query here. And what it does is that it inserts this query into the module state namespace and set it to isLoading. And then it runs the query. And what's really cool about this is that these resolvers are actually wrapped. So we can see what resolvers are actually triggered by this query, which is an insanely great debugging tool. So if you want to figure out, like, okay, I did this query, what did it actually resolve? Did it run the correct resolvers? You can actually just see that in the debugger. And when the query is, so you might have multiple resolvers down here, as I will show you soon. And then it outputs data. And this data is automatically normalized. So you don't have to define this in any way. It's actually based on the query and the schema. And of course the data that is returned. So here you see that it outputs data, author, which is the query, the type, and it gives the ID and the first name. Cool. And then it sets the result, and it changes the query state to isLoading false. So this is how it works. So if I now want to also see the posts, and I need ID and its title, I can say author post 0 title, because I will get the first, the first post in my little database here, which is test. And when I save this and we look in the debugger, we can see that we have a bigger query, and we can see that it also ran the author.post resolver, and it passed in the ID, the first name, last name of the author. And now the data is normalized to post and author. So the author has some posts, but it only gives the ID. And then we have the post in here. So this just happens automatically. And then we see that data being set. Cool. And when we look in here, we can see now it's test. So this is basically, this is the idea. You define your schema and your resolvers, and then you start using queries inside components, and that's all there is to it. Now the question is, if the data, let's look at the data here. GraphQL entities. Now, if the data looks like this, how does the component know how to build this data structure? So kind of like it grabs the data, it normalizes it, but then the component needs to denormalize it back into the query structure. And the way it does this is actually using a computed. So this query tag triggers a signal in one direction to grab the data, and then it's actually replaced with the computed, which knows about the query structure, and thus knowing where to grab the data, and kind of like builds the data back together, which is pretty cool. So now what I've implemented so far is like having an entity, and you can have relations, at least a list relation. I think I'm missing some code for like if you had a single relation here, which is not like a list. But anyways, I will get back to what's missing. So the code here, let's see. So it's kind of, I think it's structured quite nicely now. So you have like a GraphQL instance where you have the schema, where it extracts the query types, it extracts the object types. And then it runs the query where it normalizes the query. And this is where all the magic happens. This is where it sends the query, and based on the result, it will normalize it. So all this code is related to normalizing. It's not that much code, really. But okay, so that's related to normalizing. And then we have the connect, which is used on the component. It's not that much code. It's basically what I said. It's firing off the query in one direction and replacing the dependency with a computed, passing it down to the component. And then we have create computed, which has the code for bringing the normalized data back into a denormalized form. Which is also like, there's so many ways to do queries, so there are some things missing, but like the structure, like the framework for handling queries, normalizing, denormalizing, I think it's good. It's easy to extend this. Cool. I guess that's it. Yeah, and of course I have tests for all this. So there are like tests to the specific parts, and then we have the integration tests are in the connect. So here we actually fire up a controller, we define a schema and its resolvers, and we create a component that runs a query, and we see if we actually get the data back. So what the steps ahead now is to like pump in a bunch of queries. I know a couple of things that is missing that I will fix. And after those are fixed, I will push that. And I hope to get some help to at least figure out what kind of queries do we need to handle. And when we handle that, I think we should release it in the form that you need to define the resolvers in the client. And then we can work on having like a server endpoint instead, where the server has all the resolvers and stuff, and the client only needs to know about the schema. You will lose some debugging capabilities there, but that should rather be on the server anyways. So yeah, this has been like really fun to work on, a bit like mind-bending, because you have the query structure, the schema structure, and the data structure return, and all these has to match. But it's really cool to see that the concepts of Cerebral actually fits very well. Like just even the resolvers, they can, when you do a query, you can pass in a context to that query. And that context is available inside the resolvers, and that is the Cerebral context. So yeah, it just had some nice, it's kind of nice to see that it makes sense. I didn't have to hack anything. Everything just fits naturally. Okay, cool. Talk to you later, and thanks for watching.